17, 18,
11, 12,
19.
13, 14, 15,
This is
16.
sector area. And 9 and 10. All right.
11 through 16.
The word problems. All right. So remember, the sector length is r times theta. Theta.
No matter.
Where your theta has to be in what? Yes, radians. Sector. This from there to there. This is actually arc length. Sector area is my 1/2 theta times r squared. Just as a reminder, because Thursday seems so long ago. All right, number 9. An intercepted arc has a length of 19 yards. So intercepted arc, I'm using this equation. It has a length of 19. The radius is 4. Find the measure of the central angle in both radians and degrees. So if I solve this way, am I in radians or am I in degrees? Radians. This is number 9. So it doesn't have to have a pi in it to be radians. It just doesn't, it's just not degrees. So it's radians. Any is radians. Yes. Okay, so here I'm in radians. Now I need to convert over to degrees. Yes. That's what I'm trying to find. Oh my goodness. Okay, the arc length is 19. The radius is 4. Theta is what I'm trying to find. I divided both sides by 4 to get theta by itself. No, you're not. Don't say that. No, y'all stop it. All right, 19 over 4 radians. Now I need to convert to degrees. So to do that, I'm going to multiply by what? 180 over pi. So 19 over 4 times 180 over pi. You can use your calculator on this. I know, let's see, 2, 90, 45, that. I don't know what 45 times 19. 90 minus 45. Wait, don't tell. What?
If we're trying to turn it into
No. What would you say? 455? What did you say? This is degrees.
I don't know. Why would we put it in degrees?
What would be 900 minus 45? That's right. 45 times 20 would be 900. Let's take out 45 because you got 1 minute.
Number 10.
Mental math, Dozier, that mental math. All right.
I'm mental. I'm not
Radians, degrees. Yes, no, maybe so.
No.
I was just doing it in my head. For you, on your calculator, you could just say 19 times 180 divided by 4. All right. You are not reading while I am going over math. Know how to do all these. Number 10, the end of an hour hand on the clock is 5.5 inches from the center. How far will the hour hand travel over 3 full days? So this is the one where we were talking about how it's going to loop around. It's going to loop around twice for one 24-hour period, right? That doesn't even make sense.
12 hours, 6 loops.
Okay, yes.
Yeah.
Yes. I was doing for, okay, whatever. All right, so it's going to loop around a total of 6 times, yes? All right, so 6 loops around. 1 loop around is how many radians? 2 pi. So I'm talking about 12 pi radians. That is my theta. So now all I have to do, oops, wrong equation. I'm doing number 10. Homework 2. It says homework 2 at the top. Is that what you're saying? All right, so here my arc length, how far around did it travel? I'm going to do 12 pi times my hour hand is 5.5. What's that come out to be? Plus, what is it? That's right. I just did. Yes. 12 times 5 is 60, and then another half of 12 is 6. So it's 6. Oh my gosh. All right, flip it over. Then you said 17. This time, 17. What?
I asked the same question 5 times.
Okay. I'm not doing all of
Were
this.
these numbers supposed to be really big?
They could be. We'll start with 14.
My numbers for these are like.
They could have been. That's fine. This is my shaded. You have to pay special attention to what is shaded here. All right, so this is 7.1. This is 5 pi over 3. And that is the area there of the shaded, and it asked, actually, no, that's my theta. It asked me to find the area of the shaded, yes? So area is, what'd you say? Because it's in radians, it's 5 pi over 3. Yeah. If it's in radians, what? Say that one more time. If it's in radians, yes. Right. If it's in degrees, I got to convert over. One half r squared theta. Or theta r squared. I can't do this one in my head.
Wow.
5041 pi over 120. That's fine. Ah, that's
right.
good job. Good job, Caitlin. I lost my answer point. 18. A circle with a radius of 15 yards. That's the best circle I have ever drawn. 15 yards contains a sector with an area of 609 yards. So I've got this sector, and it's saying that this is 609 square yards. I know. Okay. Find the measure of the central angle of the sector in both radians and degrees. So area is 1/2 theta times r squared. And I'm trying to find this, yes? So I've got 6, they're just changing what they give you when and you're solving for it. That's all it is. But it's the same 2 equations over and over. So 1/2, this is what I'm trying to find. R is 15 squared. Multiply both sides by 2, 12, 18, 220, divide by 225. This, I'm sure this simplifies some. No? 406 over 75. This is radians, yes? Yes, because it always spits me back out in radians because I have to plug in radians as well. So if I need to convert over to degrees, then I take 406 over 75 and I multiply by 180 over pi. And then whatever, I don't know what that comes up. I can divide them both by 5. 5, 1, 15, 36. Oh, I can divide by 3. I don't know. What's 406 times 12? Oh, I could have done it, but my brain hurts. 5, 5. Radians. That's my angle. Oh, degrees. 19? Ooh. I'm sorry, what did you say there? 16. We'll do 16, then we'll do 19. 16. 4872 over 5 pi. Yeah. I don't want those. Huh? Tomorrow maybe? Maybe Thursday. Maybe Wednesday. Where's everybody Thursday?
Tuesday. Yeah, where are we going after field day then? I don't know.
Which one am I doing?
No, we're working on 16, Miguel.
I'm gonna come back to 19. All right. Area of the sector. So I'm gonna do 1/2 radius squared times theta. Write it like what?
Doesn't matter.
It doesn't matter. Order doesn't matter. Bro, it don't matter. I will. Bet you still get the same answer. Somebody tell me what that comes out to be. Square meters. No. All right, uno más. 19, a wall clock is divided equally into 12 sections. Is that 12? The clock. It is. Okay, the clock reads 8 o'clock and it has a diameter of 12.5 inches. So 8 o'clock here. So that means if the diameter is 12.5, then my radius is going to be 6.25. Do you agree? Find the area of the smaller sector formed by the minute and hour hand. 8 o'clock looks like that, yes? So, but it's got to be in radians because I'm plugging in that formula, right? So 2 pi over 12, right? Because I got 12 sections. But that is a third. Then I'm going to multiply it by it. Each one of these sections is pi over 6. Okay? So I've got 1, 2, 3, 4 because there's 2 pi in the entire circle. Well, but my theta is going to be 1, 2, 3, 4 of those. 4 pi's over 6, which is 2 pi over 3. So this is saying each one of these is pi over 6. Because if you take 2 pi and you divide it out by all of the sections, right, that's going to give me the pi over 6. Okay. All right. Now, I need the area. 1/2. R is 6.25. If you left it as 12.5, that's diameter, you had to cut it in half to get the radius. And then I'm going to times it by the 2 pi over. Half of the diameter for the radius. Then whatever that comes out to be. Yes. It'll be easy. They're just doing basic Trig today. Oh, we can't post it.
Play the video.
All right. Nope.
We'll be ready to learn.
If I tell you again, I'm gonna take that book from you. All right. Trig. Trig.
Nothing's on the board.
Oh. I was wondering why y'all weren't paying attention like that.
You were pointing at the board. No, I don't think you caught that.
Mackenzie Taylor. No, ma'am. All right.
The other name and the full.
Trig. Trig. We only use trig with right. Well, for right now. Right triangles. That's what we're talking about. So far, you're probably very familiar with one thing to do with right triangles. What is that? Okay, a formula. Pythagorean theorem, which is what? You are kidding me.
At this time, we will simulate a
Bets.
I will keep us from doing this lesson today, Miss McGee. Come on.
Oh. All right. Right triangles. My pen's back. Right triangle means it has a 90-degree angle. Okay. Hypotenuse is the side across from the 90 degrees. It's always the longest side. Okay. Now, my theta, I can go from either of the acute. Why are they both acute? Together they have to add to 90, so each one of them has to be less than 90. So from either of the acute angles, I can go, and here's what I'm going to do. This is what you have to remember. This is Clay's favorite acronym. SOHCAHTOA, but you have to remember how to spell it correctly, or else it doesn't help you. So what we can do, and today we're just going to practice with forming the ratios of these trig functions. So for sine ratios, the sine of any angle, that's where the S comes from, is a ratio of the opposite side divided by the hypotenuse. You guys should have done this before.
Oh, man.
You should have done it in geometry.
We did.
Cosine of theta is what we call the adjacent side, and adjacent is the side that touches theta but not the hypotenuse. So if my theta is located up top, then this would be my adjacent side, this is my hypotenuse, and this is my opposite. So it depends on where my theta is. If I change my theta to be here, well, now this is the adjacent side and this is the opposite. So perspective is everything here, okay? So it's the theta that you're going from. And theta will be indicated. It'll say find the trig functions of theta, and then they'll put theta on there for you so you'll know which one you're talking about. Bless you. And then the tangent is the last. The tangent of theta, oh, I forgot to finish this one. Hypotenuse. Tangent is opposite over adjacent. Now, one that you probably have not done before are what we call the reciprocal functions. Reciprocal just means to flip them over. We have the cosecant, and cosecant is the flip of sine, okay? No, inverse is different, and we'll get to that. Cosecant of theta, if it's the flip of sine, then it is hypotenuse over what? Over opposite. That's the abbreviation. Sine is actually S-I-N-E. Cosine is actually C-O-S-I-N-E. But we use a three-letter abbreviation. Secant, and this is opposite what you think, because C and S, the C's don't go with the C's and the S's not the S's. But secant is the reciprocal of cosine, so the secant of theta would be, what do you think? Hypotenuse over adjacent. And then cotangent, S-E-C, is the reciprocal of tangent. And to find that, that is flip this one over adjacent over opposite. Okay? So what we're going to do is we're going to practice finding these ratios. However, you might have to find one of the missing sides using the Pythagorean theorem. Do y'all need me to go over Pythagorean theorem? Quickly. So yes, the Pythagorean theorem. Logan, you're not Davis. A and B are your legs. They have to be the legs. C has to be the hypotenuse. But A squared plus B squared equals C squared. So given any two sides of a right triangle, you can use that equation to solve it and find the mean. That's the Pythagorean theorem. A squared plus B squared equals C squared.
What are you talking about? This?
All right, let me show you at least one example that was 4 minutes. And that's the whole lesson. Let me show you an example, though.
I'm talking about mom real quick.
That's different. That's an inverse, and that's different. Yeah. No. I am trying to get through the very last. No. Go sit down. Go sit down. Then step in the hallway. All right. Look at number 4. Everybody, look at number 4. Let's. She's gonna find herself lacking real soon. Okay. It's just a ratio. It's just a ratio. It should be this quick. This doesn't even involve you thinking a whole lot. Notice that I have a theta. This is number 4, by the way. If you don't have it, it's coming to you. I need to do all 6 trig functions of theta. So, this is 4. If this is theta, notice I'm missing one of the sides here. I'm going to go ahead and fill that out to start with. I'm going to let that be my first step. How many more? How many more we need? How many? I don't know. This is not myself. That going outside does not help you. You don't have what? Either A or B, one of the sides. That's right. So maybe you do A squared plus B squared equals C squared. So what is 34 squared? Wait, what? I will, but I don't know this side right now yet. I got to find that. So 34 squared minus 30 squared gives me, I would leave them, so what they're doing is whenever you find the side, if I square root this to find the missing side, right? If it's not a perfect square, you might have to simplify it. In this case, it was a perfect square. Bless you. And it was 16. Well, you'll see if there's a perfect square you can divide it by. That doesn't always work. That doesn't always work for you, though. It just happens to. But I did 34 squared minus 30 squared. All right. Don't do that. Don't do that. All right, let's run through these trig functions. All I'm asking you to do on these is find that missing side and then write the ratio here, okay? All right, so sine is opposite over hypotenuse. Remember, you got to remember SOHCAHTOA. You can remember it however you want. No. Some old hag cracked all her teeth on apples was one thing my kids came up with years ago. No, you don't. One time I did an extra credit bonus assignment for who could come up with the best acronym, but everything has just about been done by now. Okay, let's go. Opposite over hypotenuse. So if this is my theta because it's indicated, that's the one I'm going from, okay? So my opposite is 30, and my hypotenuse is 34. So I'm just going to simplify it. 15 over 17. That's all you're doing on these, okay? What? Well, because I'm doing sine, cosine, tangent. You can cosine. So now for cosine, cosine is adjacent over hypotenuse. So now I'm 16 over 34, which is now the tangent. So it's 30 over 16, which is 15 over 8. All right, let's do the reciprocal ones while we're here. So cosecant, all I'm doing is I'm taking these and I'm flipping them over. Secant and cotangent. Do you see how quick that was?